children, welcome to Zero Panic Maths. In today's session, let us start the very first chapter of the new CBSE syllabus for 9th class, that is Chapter 1, the use of coordinates. Okay, and as it is said here, it is for orienting yourself regarding the coordinate system. Okay, so as an introduction, let us see first of all what is a coordinate system is. Okay, so it is a definition given in the textbook itself. You can go through that also. So a system of coordinates is a structured framework, okay, and it is given as an example, okay, like the grid lines on a map. Okay, you might have seen the grid lines on a map which are given in the form of squares intersected with the horizontal and vertical lines. Okay, grid lines of a map or a graph paper. Okay, and that system that enables us to use numbers to describe the exact physical location of a point or objects. Okay, it's nothing but a simple system where there are vertical and horizontal lines are given, and using the numbers you can pinpoint the exact point or the location of a point or the object. So this is called as a point. Okay, so such a system is called as a coordinate system. It's a simple definition. Okay, so any point in two-dimensional plane, this is a two-dimensional plane. It is a plane. Assume that this is a plane paper and this is a two-dimensional. Why it is called as two-dimensional? Because one is horizontal and one is vertical. That's why. Okay, there are vertical and horizontal lines. So two-dimensional plane could be defined by simply two numbers. Okay, and what are those two numbers? Representing the points distance from two perpendicular axes. Okay, so suppose this is one axis and this is one axis. These are perpendicular because they make a 90-degree angle here. Okay, so it is with the two numbers that we are representing this exact point, and that is the perpendicular distance from this. See, this is one distance. So assume that this is the point and we want to point the location of that point, then this is the perpendicular distance from this axis y, which is called as, and this is also a perpendicular distance from the x-axis. So that's why it says, the second point says, any point in two-dimensional plane, okay, any could be defined by simply two numbers. And what are those two numbers? It is the distance, vertical distance, and horizontal distance and a vertical distance. So we will also see in this chapter that how we are using this coordinate system to represent the algebraic equations and also the geometrical shapes, and vice versa also, because the geometrical shapes like triangles, rectangles, we can represent on the graphs in a two-dimensional plane, and the other way also. Okay, so we will see. This is a simple introduction of this. Introduction 1.1. Okay, let us see what else is given based on this. Okay, in 1.2 there are some historical background given about the coordinate system, who invented it and what all. Some historical details are given. I have not taken that as part of this session. You can go through that in the book. Okay, the next concept here is the two-dimensional Cartesian coordinate system. You can simply call it as 2D. Okay, that is in short we can call it as 2D space. 2D means two-dimensional only, nothing else. Okay, so the two-dimensional coordinate system uses two number lines. Now, in the last year, if you remember, you have used a number line system. Okay, there is a number system. There was a number system chapter, right, in which we have studied one line to represent numbers starting from 0 in the middle, and there are 1, 2, 3, like this on the right side, the positive numbers, and the negative integers -1, -2, and -3, like this. Okay, now assume that there are two such number lines that actually say right angle to each other. They are saying two number lines. So this is one number line, and suppose there is a perpendicular, similarly 0 and taking 1, 2, 3 and so on the upper side, and down again -1, -2, -3 like this, and 0 in the middle. Okay, so assume that this is 0. This is 0 for horizontal line, this is 0 for vertical line also. So this two-dimensional coordinate system is nothing but the intersection of the two number lines and intersected or right angle to each other to mark points in two-dimensional space. Okay, so right angled at a point 0. So this is what two-dimensional coordinate space is. And consider one of the lines to be horizontal. So we have considered this is one of the line which is horizontal, and that is called as x-axis. This is called as x-axis. Okay, and the other lines is vertical and it is called as y-axis. This is x-axis, this is y-axis. Suppose this is y-axis. It is a vertical one and it is y-axis. The point of intersection of x-axis and y-axis is called its origin. O. So there is a point of intersection, and where the x-axis and y-axis of this system intersect with each other, and that is called as origin. What is this is called as origin, and the point the coordinates of this origin are 0 0, because see, it is the point of intersection where 0 for x is also there and 0 for y coordinate also. So if this is a y axis, this is the x axis, 0 is the point for both x and y coordinates there. So that's why the coordinate system is represented by the two numbers 0 0 for the origin. Okay, are you following this? Okay, now next, while writing the coordinates of a point, it is often convenient to drop the equal to sign. So this point actually is saying, suppose there is a point here. Let us take some examples by this. Okay, so this is the graph. There is a one graph image I have taken here, and assuming that, see, this is one number line with 0 in the center, 1 2 3 4 5 positive towards the right side, towards the left side negative x-axis which represents the negative integers, and then towards the upper side positive integers with positive y-axis, and downside there are negative integers with negative y-axis. Okay, now this is, see, origin's coordinate, we usually represent them as o is equal to 0 0. 0 x-axis and y-axis. We always represent the value of x-axis first and y-axis next. Remember this. Okay, so this point says that instead of writing the value like this, say suppose there is a point P, and if you are representing the coordinates x y like this, then this is often not needed to represent equal to. You can just remove that or drop that equal to for convenience, and you can write the points like this directly. Okay, P of xy, that also represents the point only. That is what the meaning of this last point. Okay, now let us see this graph again, and let us try to represent different points on the coordinates. This is a two-dimensional coordinate system in which we are trying to represent different values and different points. Okay, exactly how can I represent this? Okay, now see, mark the below points. There is a point B whose x-axis, as I already told, the first value in the bracket is x-axis. We always represent the coordinate value into the brackets, and the brackets first value is always the x coordinate value, and the second is y coordinate value. Okay, okay, now you see that 4.5 is x coordinate value. X coordinate positive, x is towards the right side from the origin always. So this is origin, okay, whose coordinates are 0 and 0. You remember that always. Okay, now it says B, point B 4.5. See, this is 4.5. So this is 4.5. And what is y-axis? Y-axis is 0 only. So 0 for y-axis is this. So that's why, see, in between these two vertical lines there are 10 lines. So in the exact center of these two vertical lines, you might find the fifth line which is little bit darker as compared to the other lines. This point is actually B. Okay, This point is B, and what is the value of this point? 4.5, and y coordinate is 0. So this is how you represent these points. Okay. Now what is G? G is x coordinate 0. X coordinate 0 is exactly in the origin itself, and it says minus 4.5 for the y axis value. So where is y axis minus value? Is towards the downline. Correct? Okay. So what is minus 4.5? Then minus 4.5, considering x as 0. Okay, this is that G. This is the G. You need to mark it very carefully. Okay, it is minus 4.5. 0 for the x-axis and minus 4.5 for the y-axis. Now similarly, you can see minus 2.9 for x-axis and 0 for y-axis. So again, x-axis negative value is towards the left side from the origin, and it is 2.9. So this is that point, 2.9. And what is this? E minus 2.9, and the y coordinate is 0. Okay, it is on the axis itself. All these 4 points that they have mentioned here are all on the axis itself, where either the x is 0 and or the y coordinate value is also 0. Even if you see the h value, it is actually 0 for x axis, and towards the positive y axis it is that 0, 4, which is the point h. 0 for x axis and 4 for y axis. This is how you represent the values on the coordinate system. Okay, now apart from zeros for either x or y coordinates, if they are given, they will fall under these sections of this coordinate system. And what do we call them? All that we will see in the next coming session. So based on this, let us see some example. It says the following figure shows Rian's room with points O, A, B, C marking its corners. Okay, so there is a figure given here. Let me take that figure in the next this one. Okay, so it says O, you can see that there is a figure given for the room. Okay, and they are saying there is it can be considered with the help of a coordinate system, two-dimensional coordinate system. And O, A, B, C. Okay, O, A, B, C, they are saying this is a Rian's room. Okay, representing Rian's room. Okay, now what else they are saying? Okay, point O is the origin. Okay, we know that this is a point O and this is origin. Okay, now next, referring to the figure, answer the following questions. If D1 R1 represents the door to Rian's room, D1 R1 is door to the Rian's room. How far is the door from the left wall? Left wall, that is y-axis, that they are saying y-axis of the room. Okay, this is first question. Second is, how far is the door from x-axis? Okay, so let us see the figure. It's very simple. They are saying see, this is the origin. So since they have given 0, 0 as the value for this point, this can be considered as origin. And towards the right side horizontal, whatever you see, that is x-axis, and they have mentioned that also here. And vertically, whatever you see the positive values, those are y-axis, and that y-axis itself they are calling it as left wall, because if you consider this room, this is left wall and this is right wall, this is x-axis, this is x-axis. Then what they are saying, the question, the first question is, if D1 R1, see that question there. Okay, D1 R1 is the entry to the room or the door to this room, then how far is the door from the y-axis? How far is the door from the y-axis? This distance we need to tell them. Okay, that is first question. And second is, how far is this door from the x-axis? As you can see, it is on the x-axis only, so there is no distance from x-axis. It is on the x-axis itself, so you can say it is 0 feet or 0 unit distance only. Okay, now let us consider the scale. Okay, considering the scale, I'll just write here, consider the scale as, what is the scale? Scale as 1 feet is equal to 1 unit. 1 feet is equal to 1 unit. It means that, so this distance, that 1 unit is 1 feet. I'm considering that scale for this graph, this diagram. You understood that? Okay. So now, how do I find out the distance d1 from the y-axis? It is actually the horizontal distance between the x coordinate value of d1 minus the x coordinate value of the origin, because it is from the origin itself. It is on the x-axis and parallel to x-axis. Okay, try to understand this. Because the y coordinate value is a 0 here, y coordinate value is a 0, it has only the x coordinate value. So what is the coordinate value of d1 here? What is the coordinate value? It is 8 and 0, right? Coordinate value is 8 because x axis is 8 and y is 0. So it is actually the coordinate, the difference between the x coordinate value of d1 minus the x coordinate value of origin, that actually gives us the distance of this point d1, distance from the door of the door from the y-axis. Okay, so that is what I'm going to write here. Okay, so if d1 r1 represents the door's Rian's room, door to the Rian's room, then I can say the distance of door is equal to x coordinate of d1 minus x coordinate of, so x coordinate of d1 minus x coordinate of origin. Okay, I can say that, right? Okay, so where is that? Okay, x coordinate of d1 minus x coordinate of origin, x coordinate of origin. Okay, now what is x coordinate of d1? As we have already seen, it is 8. And what is x coordinate of origin? Origins x and y coordinate both are zeros, so it is 8, and that is 8 feet. That is 8 feet because we have considered the scale as 1 feet is equal to 1 unit, or you can say 8 unit also, that is also fine. Okay, so the answer to the first question is, from the left wall it is 8 feet wider towards the right side. Okay, how far is the door from the x-axis? From x-axis it is 0 feet. Okay, from x-axis 0 feet because it is on the x-axis itself. Okay, so this is the answer to the first question. You understood this regarding this diagram? Okay, let us see any question is there. Next question. Okay, what is second question? Oh, sorry, I've left one more question here. What are the coordinates of d1? Okay, we have already represented what are the coordinates of d1. What are the coordinates of d1? It is x coordinate 8 and 0 is the y coordinate. Okay, so let me just say x coordinate. Second question, the x coordinate, sorry, the coordinate value for d1 is 8, 0. 8 for x-axis and 0 for y-axis. That's all. Okay, now let us see the third question. Third question is, if r1 is the point 11.50 on the x-axis and 0 on the y-axis, that you can see it here, r1 is this. Okay, they are saying, what is the question? They are saying, how wide is the door? We need to find out the width of the door. Okay, you can see that. So our door starts at point d1, and this is the door, starting of the door, and this is the end of the door. Okay, where exactly is that? 11.5. So this is the width of the door. We need to find out this first. Okay, that is the actual question. Okay, that is, first of all we need to find out the width of the door, and the next question are some simple questions, that do you think this door is comfortable width for the room door? Okay, for the room door, whether it is okay to have 3.5 as it is given here, 3.5 width will be sufficient for the room door or not. That is what some question. Next question. And if a person in a wheelchair wants to enter the room, will she or he be able to do it easily, whether they can easily enter that room or not? Those are all the simple questions. So for the main important question is to find out the width of the door. Okay, given this, given this. Okay, now let us just check how do I find out the door width. Okay, now from given figure, from given figure or given diagram, you can say that from the given figure or diagram, you can say that uh, the door, the coordinates of the door, you can say coordinates of the door, coordinates of the door extend from, you can say extend from D1 to R1, correct? So therefore width of the door, you can simply say width of the door, width of the door is equal to x coordinate of R1 minus x coordinate of D1. That's all right. See, it is x coordinate of R1 and x coordinate of D1 itself, because the y coordinate value is 0 here. Okay, so we will do that only. It is x coordinate of R1, x coordinate of R1 minus x coordinate of D1, x coordinate of D1. And what is x coordinate of R1? Because it is 11.5 here and y is 0, it is 11.5. And what is x coordinate of D1? We have already seen, that is 8, right? So what is this? It is 3.5 feet, because the scale we have considered is 1 feet is equal to 1 unit. It is 3.5 units. So the distance is, the width of the door to that room is 3.5 feet. Okay, so this is the answer. The second question answer, you can say, okay, is this a comfortable? Okay, for any door, 3.5 feet of the door is comfortable width for any door. So for the second question also, you can write yes, it is comfortable. You can write it simply. And if a person with wheelchair, okay, a wheelchair can be entered into that room with that 3.5 width door, okay, it is possible. Okay, so you can say yes for this also. Yes, he or she with a wheelchair can enter this room easily with a width of 3.5 feet door. Okay, you can say that. Okay, so that is what the answer to this question. Okay, now there is one more question. Fourth question regarding that figure only, referring to the figure, answer one more question. If B1, which is 0 for the x-axis and 1.5, it is towards, this point is towards the y-axis. It means that it is towards the y-axis. B1 and B2 is 0, 4, represent the ends of the bathroom door. Okay, is the bathroom door narrower or wider than the room door? We need to find out the width of the bathroom door given in the figure, and find out whether that bathroom door is narrower or smaller than the room door, or whether it is larger than the room door. That is what we need to find out. Okay, let us see what are those points B1 and B2 here. See, it is the point here given. It is B1 and it is B2. And what are the points? See, towards the y-axis it is. Okay, it is y-axis actually. It is y-axis and it is x-axis. So it is 1.5 for the y-axis, but for the x-axis it is 0 only. Okay, so x-axis 0 and it is 1.5. And what is this? What is this? B2. B2 is 0 for the x-axis and 4 for the y-axis. Okay, so this distance we need to find out, which is actually the width of the bathroom door, assuming that there will be a bathroom that comes here at the left side of this. This is the room, okay, and this is bathroom. This is the entry to that bathroom. We will see one more picture, one more figure extending the bathroom at the left hand side. Okay, that comes in the next problem. Okay, we need to find out this width of this door, and then we will compare the width of this door with the width of this door and find out whether it is narrower or smaller. Okay, okay, now let us see that. The points are given already here. Now since you can say, since x coordinate value is x is 0 here, x is 0 here, the distance b1 b2, which is the width of the bathroom door, okay, you can say the distance b1 b2, the distance b1 b2, which is equal to you can say here, which is equal to width of the bathroom door, width of the bathroom door, width of the bathroom door is equal to y coordinate of b2 minus y coordinate of b1, because x coordinate is 0, x coordinate is 0. So I can say y coordinate of b1 b2, y coordinate of b2 minus y coordinate of b1. Okay, so what is b2's y coordinate, which is 4, minus what is b1 y coordinate, it is 1.5. Okay, so it is a 2.5. What is this? 2.5 feet. So it is the width of the bathroom door is 2.5, which is little bit small, 1 feet smaller, exactly 1 feet smaller as compared to the door to the room. Okay, so therefore bathroom door, we can say that bathroom door is 1 feet, exactly 1 feet or 1 unit, you can say narrower than 1 feet narrower than room door. Correct? So this is the answer to this question also. You understood this? Okay. Let us see the next concept. Okay. What is the next concept? So the next concept says about the Cartesian plane, coordinate plane, or XY plane. All these are same only. These are the alternative names given to the two-dimensional plane that what we have studied till now. Okay. So that is called as Cartesian plane or coordinate plane or XY plane, because there is a point which represents x coordinate horizontally and y coordinate vertically. So simple definition is the plane in which the axes are situated. Axis is nothing but the plural form of axis, one value, or the horizontal or vertical. Okay, the axes divide the plane into 4 parts called quadrants. So as we have seen, so there is a vertical line, there is a horizontal line. It divides the given plane into 4 parts. This is 1, 2, this is third part, and this is fourth part, and all these 4 parts are called as quadrants. Name, remember this name, those are called as quadrants. Okay, so you can see that here simply given. Okay, now assume that this is a plane and there is a horizontal line representing positive negative integers horizontally and positive negative integers vertically. Then this plane divides the given plane into 4 different parts, and those are called as quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, remember here, very important thing is you should always call the right top corner, this part, only as quadrant 1. You cannot say, since it is divided into 4 parts, any part is called as quadrant 1. It's not like that. Okay, why? I will tell you that. Okay, so this right top corner quadrant itself, this part itself is called as quadrant 1, and anti-clockwise we will move to represent the next subsequent quadrants. Okay, it is quadrant 1 in the right top corner, left side it is quadrant 2, move anti-clockwise, quadrant 3 here, and finally quadrant 4 here. Okay, see, if you observe something here, as the coordinate system that intersects x-axis y-axis is 0 0, any point on the quadrant 1 will have both x coordinate and y coordinate value as positive only, because you always represent a positive x axis and positive y axis. This part is positive x and positive y axis. Say for example, there is a point here, there is a point here. What is the x coordinate value? This is the horizontal distance from y axis. This is that, it is 4, it is 4 for x axis. What is y axis? It is 3 here, you see that. So if you horizontally and vertically, if you point out, this is that point, and 4 is the x coordinate value and 3 is the y coordinate value. Okay, so any point in this quadrant 1, if you point out, that will have both x axis and y axis as positive only. Okay, that is what the meaning of this. Okay, now in the second quadrant it will be little bit of different, because the y coordinate value for the second quadrant is positive, but x coordinate value is negative. You can see that it is q, the q value, the point q. What is this? See, what is this? If you see, this point is -5 for x coordinate. X coordinate is negative, x coordinate is negative, whereas y coordinate is positive here. Y coordinate is positive. So in the second quadrant, x is negative, y is positive. Okay, in first quadrant both are positive. Here in the third quadrant both are negative. You can see that. If you say for example, this is the point, then -4 is the y coordinate, sorry, -4 is the x coordinate, and -3 is the y coordinate. You see that. So in the third quadrant, both x, y are negative. Okay. And if you come here in the quadrant 4, it is contrary to quadrant 2, that x coordinate is positive. You see that x coordinate is positive, but y coordinate is negative. Suppose this is the point. If I am considering, then this is that. So x coordinate is 3 and y coordinate is -3. You understood this? Simple definition. By looking at the plane itself, you can see that quadrant 1, both are positive. Quadrant 2, y is positive, but x is negative. Quadrant 3, both are negative. Quadrant 4, x is positive, but y is negative. This is what you need to remember. Okay. So that is what the explanation given here in the previous slide, that the points in quadrant 1 both have x and y coordinate positive. Second quadrant, that is what I just explained here, and the explanation is given in the previous slide. Okay. Okay, now based on this, let us see what is given in exercise set 1.2. Okay, on a graph sheet, this is a graph sheet. Mark the x-axis and y-axis and origin as 0. Mark the points from -7 to 0 to 13 0 on the x-axis. On the x-axis, they want us to represent -7 to 13. It means that -7 to 13 on the x-axis. Okay, and from -15 to 12, that is 0 -15 to 0 12 towards the positive y-axis, they want us to represent, and using the scale as 1 centimeter is equal to 1 unit. So here 1 centimeter, whatever you consider, that they want us to consider it as 1 centimeter is equal to 1 unit. Okay, 1, it is 1 2 3 4 5 11 12. Okay, now we have created the graph sheet according to the scale given here. Okay, let us see what are the examples, or what are the questions based on this figure. So this is the figure, as I already told you, that this was the room, the Riam's bedroom, okay, where D1 R1 was the entry to the room, okay. This is the door to the room, and this was from 1.5. So this is from 1.5 to 4, okay. This is actually Riam's entry to the bathroom. So this is bathroom, this is the bathroom, okay. Can you see this, the point B1 and B2 here, okay, and D1 R1 is the another room, okay. Now let us see, with reference to this figure, we will see the different examples for which we need to answer some questions, okay. Now place Rian's rectangular study table with three of its feet at the points 8 9, 11 9, and 11 7. So now as we can see that there are 3 points given, okay. There is a rectangular table, of which 4 points we need to represent, but out of the 4 points, 3 points they have given, 8 9, 11 9, and 11 7. You can observe that all those points are positive x-axis and positive y-axis only, so it is going to fall inside the first quadrant only, okay. Now according to the given figure here, this is the origin, which is 0 0, and towards x-axis and y-axis, this room, the Rian's room, is actually first quadrant, and bathroom is second quadrant, because you see that the negative values for the x-axis and y-axis obviously is a positive one. So bathroom is in the second quadrant, and in the first quadrant we have the room, okay. So they are asking us to point out the 3 points. Suppose that this the 3 legs of the rectangular table, suppose that this is L1, the leg 1, leg 2, and leg 3. Assume that this, okay. And they are asking, the first question is, where will be the fourth feet of the table, fourth foot of the table be, okay. So let us assume that is L4. We need to find out that fourth point where the fourth leg of the rectangular table will be placed. And the second question is whether it is a good spot for the table, and what is the width of the table, the length of the table, and can you make out the height of the table with the given information. Can we find out the height of the table? That is what their question is. So let us first try the first question. First question, let us represent the 4 points. What are the 4 points? 8 9, okay. Now 8 9, where is 8 9? This is 8 and this is 9, okay. Let us represent that in the graph itself, because we have the graph here, okay. So this is 8, okay, taking horizontally 8 9. So here it is 8 and this is 9, this is 8 9, and assume that this is L1. 8 9 is L1, okay. What is the second point? Second point is 11 9 and 11 7, okay. So let us represent those also. 11 towards the x-axis and 9, this is L2, okay. 11 9, it is L2, and it is next is 11 7, 11 7, 7 towards the y-axis, this is L3. So obviously, if there is a rectangular table and it is placed like this, L1, the first leg here, second leg here, third leg here, so fourth leg will be exactly here only, and this is L4. And what are the coordinates of that? 8 towards the x-axis and 7 towards the y-axis. That's all the answer to the first question. You understood this? Okay. Let us represent that in the room and see 8 9. Okay, you see that the it is 1 2 3 4 5 6 7 8 9 here, 9 here, so it is 8 8 and 9, it is that first L1. 11 9, 11 9 is this. Next is 11 7, and the last one L4, that is 11 sorry 8 7, right, 8 7. So this is the table, this is the table which is placed. You understood this? Okay. Now answer to the first question. Referring to the graph, you can say that referring to the graph, the fourth feet of the table, fourth foot, you can say the fourth foot of the table is equal to L4, sorry, L4 is equal to, what is that? 8, 7. 8, 7. Is that correct? 8, 7. See that? 8, 7, 8 x-axis and y-axis, this one. Assuming L1, L2, L3, L4 are the four legs of table. You can write that also for convenience. You can write it here. Assuming L1, L2, L3 and L4 as 4 foots of table. 4 foots of table. Okay. So that is the first answer to the first question. Second is this a good spot for the table? It is like a generic question. We can say that we always see, generally in general, the tables will be, the study tables will be always placed in the corner of the room so that it will not be an obstacle inside the room. Okay. So that's why usually the tables are placed in the corner of the table. Here, if you see in the figure itself, if you see, it is in the corner of the table except 1 feet here and 1 feet here, because you see there is something given here also in the corner of the room. There is a flower pot placed. Okay, so it is not, so maybe tactically they are asking us whether we are able to answer to this question or not. Okay, so according to me, this is a good position because there is already a flower pot given in the corner of the room. Okay, if that would not have been there, then this table would have been pushed a little bit more to place that in the absolute corner of the room. Okay, so that's what generically we need to answer to the second question. The second question is this the good spot for the table? Yes, it is a good spot since the flower pot is also placed in the corner of the table. Okay, so as the second question, answer to the second question, you can write yes, it is a good spot. It is a good spot. Okay, good spot since in the corner of the room there is a flower pot. In the corner of the room, you can say there is a flower pot. There is a flower pot. You can answer that. Okay, now next question is, what is the width of the table? The length of the table. Now how do you find out the width and length of the table? Is width is the distance between the x coordinate values of any two corners of the table, and the length is the y coordinate difference between the any 2 points, the horizontal or parallel any 2 points. Okay, and the last question is it possible, can you make out the height of the table? Okay, no, we cannot find out the height of the table because it is a two-dimensional figure. It is a two-dimensional, and the two dimensions are width and length only. We can find out the third dimension length is not possible to represent here. Okay, so now can we find out the width and height? Yes, we can find out by this. So what is this? L3's value is 11 in the x coordinate and 7. 11, 7 is the y coordinate. Okay, now what is the L1? L1 is the first leg, so that I can find out the length also. So by looking at the figure, you can see that 3 feet is the width and 2 feet is the length here, but mathematically we need to find out that. That's why I'm representing this coordinate values also. So 8 and 9, it is 8, 9. So you can say width of the table is x coordinate difference between L3, L4, and length is y coordinate difference between the length L1 and L4. Okay, you can always say that. So it is 8987. First of all, find out the length. Okay, the third question, answer to the third question. Length of the table, length of the table is equal to, length of the table is equal to y coordinate value of L1 and L4. Okay, y coordinate difference, or you can say y coordinate of L1 minus y coordinate of L4. Okay, is it that? L1, L4. That is 9 minus 7. It is 2 feet. Understood? Understood this? Okay. So that is 9 minus 7, which is 2 feet. 2 feet is the length of the table. Similarly, okay, I will leave it to you. Similarly, you can say width of the table is x coordinate of L4, x coordinate of L4, and this is L3. L3 is, what is L3? Is the 11 x coordinate and 7 y coordinate. It is x coordinate of L3 minus x coordinate of L4. It is 11 minus 8, which is 3 feet. Will you write that? Okay, so that is a simple, assume that simple homework for you, that width of the table is equal to x coordinate of L4 minus x coordinate of L2 or L3. It is L3, sorry, L3, x coordinate of L3, which is 11, x coordinate of L4, which is 8, value 8. So it will be like 11 minus 8, which is 3 feet, is the width of the table. You need to write that. Okay, so that completes the first question. What is the second question? Okay, referring to the figure, I've given the figure once again because all these questions are based on the same figure itself. Okay, now if the bathroom door has a hinge at point B1, okay, now let us consider this is point B1. We know that this is 1.5, point B1 and point B2. Okay, now this is that door. They are saying there is a hinge at point B1, and if I open the door in the room side, okay, they are saying B1 and opens into the bedroom. Okay, assuming that, listen carefully, assume this door which is of 2.5 feet. We know that we have already found out the value of B1 to B2, that is 2.5. If it opens in the room like this, whether it will hit the wardrobe, that is what the question is. Okay, let us see that will it hit the wardrobe? Will it hit the wardrobe? Generally, you see that. And how far is the wardrobe, the start of the wardrobe from the origin or from the left wall? From the left wall, it is 3 feet, right? And what is the width of this door? From here, it is 2.5. So now tell me, will it hit the wardrobe? No, because it is 3 feet distance. There is a 3 feet difference here, and the width of the door is 2.5. So it will not hit the wardrobe. Okay, that is first point. Second point is, are there any changes would you suggest if the door is made wider? Now they are asking whether if the door is made little bit wider, is there any suggestions that you can suggest? Okay, listen to me carefully. Wardrobe is from 3 to 7, so it is 4 feet. Wardrobe is 3 feet, and from point D1 you already know that there is a door that starts. Okay, so even if you push the wardrobe little bit towards the right side, so that the wider door than the 2.5, suppose if you made it 3, okay, or 3.5, suppose, then only 1 feet can be moved as the towards the right hand side, because after 1 feet there will be a door that comes here. Okay, so why, that is one suggestion that we can suggest. Or else they might be asking, it is a generic question, so answer differs here. Answer differs. Listen to me carefully. So if suppose wardrobe cannot be moved to the right side, then there is no changes that you can suggest for the widening of the room door, the bathroom door. Widening of the bathroom door cannot be done because wardrobe cannot be moved to the right side. So it depends on how do you assume your calculations. Okay, so that is what the answer to the generic question. So let one B2 is the width of the door. Okay, width of the bathroom door. Okay, here we know that we can say that we know that bathroom door, or you can say width of the bathroom door, width of the bathroom door is B1 B2, right? B1 B2, and that is equal to 2.5 feet, right? 2.5 feet. Okay, and the distance of the wardrobe, that also we need to start, right? So the distance of the wardrobe from the left wall is 3 feet because it is x coordinate 3 minus 0. Okay, from the figure, and wardrobe, it depends on you that how do you make out, or how do you frame these sentences. Okay, wardrobe start at 3 feet from left wall, 3 feet from left wall. Okay, left wall. So the door will not hit the wardrobe, door will not hit the wardrobe currently. Okay, hit the wardrobe. So this is the answer to the first question. Because it is 2.5 width and 3 feet space is already there, it will not hit the wardrobe. That is the first part. Second part is, are there any changes you would suggest if the door is made a little bit wider? Okay, and finally, now you can say, if the door is widened, then there is only 1 feet, there is only 1 feet space available, 1 feet space available to move the wardrobe to right side, to move the wardrobe to the right side. Now, as I already told you, this part of the question, there will be different answers coming from different analysis, because I am saying, as I already told you, I am saying it is possible to move this wardrobe towards the right side. Okay, but some might analyze in a way that, okay, we cannot move the wardrobe towards the exact position of the door. So in that case, there are no suggestions, only there cannot be any changes in that. So that is the reason I told you that the answer to this, the second part of this question, may differ based on the way that you analyze the question. Okay, you understood this? Okay, now let us see the next. Okay, now again I have placed this here. Okay, now look at Rian's bathroom. The third question is, look at the Rian's bathroom. What are the coordinates of the four corners OFRP of the bathroom? Okay, let us see that. This is the bathroom, and this is O, sorry, the coordinate OFRP. Okay, now they are asking, what are the coordinates OFRP? We can easily find out that also. Now, what is the shape of the showering area SHWR? Okay, listen to me carefully. This is the showering area SHWR. Now tell me what is the shape of this? Okay, it looks like a trapezium because there are two parallel lines and there are two unparallel lines. So a figure with 4 points, four coordinates, sorry, four corners with one opposite side as parallel is a trapezium. So the shape of the showering area is a trapezium here. The second question, answer to the second question. Third is mark of 3 into 2 feet space for the wash basin and 2 by 3 space for the toilet, and write the coordinates of the corners of these spaces also. Okay, now let us see that. Okay. Okay. Now let us see first question. What is the first question? Listen carefully. What are the coordinates of the four corners OFRP? Okay, now let us see those first. O is 0, 0. Okay, first question. First question. O is, now I will just write the coordinates. You can just write that. Okay. O obviously is the origin of the graph. So it is 0, 0. F, see, F is 0 for x-axis and 9 for y-axis. That you know that already. Okay. Because it is 10. See, C0 is, sorry, C is 0, 10. So it is 0, 9. Okay. So what is next point is F, and it is 0 x-axis and 9 y coordinate. Okay. So the third is this one. It is actually see -6 towards the x-axis. So it is -6, and we know that this is 9. This is 9 already here. So -6, 9 is the coordinate value of R. Okay. -6, 9. And finally it is P. It is P, which is also minus P, but y coordinate value is 0. Y coordinate is 0, x coordinate is -6. So it is -6, 0. -6, 0. You understood this? Okay. Now, second question. What is the shape of the showering SHWR, showering area? The shape is trapezium. Okay, you can write that yourself. Okay, the shape is trapezium. I'll just write the coordinates of that. Okay, so answer to the second question. The shape of showering area. Shape of showering area is trapezium. Now, if you want, you can write the uh, reason for that also, because the two sides of the rectangle are parallel to each other and the other two sides are non-parallel. So that's why it is a trapezium. Okay. And what is the next part of this? Write the coordinates of the four corners. So how do I find out the coordinates? Yes, you can see yes is 6. Okay. It is -6. And what is the y coordinate value of that? You can see that. What is this? -5, -6. Sorry, 6 it is. Positive 6. Okay. Okay. H value is -3, and as it is 6. It is 6 towards the y-axis. And here it is -2. W it is -2 and 9. We know that this is the y-axis. And R we already know that it is -6, -9. Okay. It is SHWR. Correct? SHWR. Okay. Now coordinates, as we have already marked here, coordinates are -6, 6, -3, 6. Okay. Yes, -6 and 6. And yes, R is -3 and 6. R. Next is W. W is, what is W? W is -2. Correct? It is -2, -2, 9. W is -2, 9. Finally it is SHWR. R we already know, -6, 9. Okay, -6, 9. These are the coordinates of the four corners of the trapezium, which is a showering area. Okay. Now the third question is mark of okay. Now two points we need to mark, that is 3 by 2 feet space for wash basin, okay, and 2 by 3 space for the toilet. Okay, now you listen to me carefully here. Okay, so here it is wash basin given here and there is a toilet here. Okay, so they are saying 3 by 2 space for the wash basin. Okay, now this is 3 towards the width and this is the length. Okay, so this is wash basin. If I consider this is wash basin, and 2 by 3 for the 2 by 3 starting from here, 2 by 3 for the toilet. So this is the toilet. You understood this? Okay, so we need to find out the four coordinates of this also. Okay, now assume that this is P, or else I can say it is wash basin, right? Whether it is W1, W2 given here, okay, W is given here, okay, W1, W2 is given here. Wash basin, I can say B1, B2, okay. So starting from B1, B2, okay, B3 and B4 are the four corners of the wash basin area, and toilet area are before it is already given here. I can say T1 for representing this point only, toilet 1, okay, T1, it is T2, this point is T2, this is T3 and this is T4. This area it is 3 by 2 space. Okay, it is 2 by 3 for the toilet, 2 feet width and 3 feet height. You can see that. Okay, so we need to find out the corners of this. What is B1? It is -60. Okay, okay, now let me write that. The third question to the answer to the third question. Okay, assuming uh, B1, B2, right? The wash basin B1, B2, B3, B4 as the wash basin area, as the wash basin area with, what is that, 3 by 2 3 by 2 feet space, 3 by 2 feet space as mentioned in the question. 3 by 2 we have mentioned. Okay, so the coordinates are, you need to mark that. Okay, coordinates are, okay. Now one more important point I forgot to tell you, that I am mentioning all these points here in the page itself. Sorry, the on the figure itself. You need to mark it on the graph that we initially considered. Okay, so that will be easy to find out the points here. Of course, there are points given on the figure itself. You can figure it out, but it will be easy if you plot it on the graph. Okay, take a graph, plot all these points by taking the four quadrants, and then it will be easy for us to find out all these values. Okay, now the coordinates are -60, -30. Okay, for B1, B2. Okay, it is -60, -60. Is it 0 or what? So it is on the 0, on the x-axis itself. So it is -60, -30 and -3, 2 for B3. Okay, okay, so it is taking a little bit of time. Okay, B1, B2 is, because it is 3 feet wider, it is -30. Okay, now finally B3, the third point, it is on the third x-axis, towards x-axis it is -3 only. Okay, -3 only, and towards y-axis it is 2. Okay, and B4 it is -6 in the x-axis. You can see that here, -6 in the x-axis and 2 in the y-axis. So B4 is -6, 2. Okay. minus 6 2. B4 is minus 6 2. So these are the coordinates of the area 3 by 2 feet space for the wash basin. Okay, now the coordinates of, similarly the coordinates of toilet area, similarly the coordinates of toilet area, coordinates of toilet area. What is toilet area coordinates? Let us refer the figure again. Okay, it is before the point T1 is before only. Okay, what is T2 here? T2 here minus 4 and 2, minus 4 2. Okay, write down these points and write it at the end. Okay, I will not write it again. Okay, T1 which is minus 6 2, sorry, it is which is equal to, before it is minus 6 2. I will write it here, minus 6 and 2 towards the y-axis. T2 is minus 4 2. I will not write it again, you have to make a note of all this. Okay, minus 4 is T3 x-axis, and towards the y-axis it is 1 2 3 4 5. It is 5 here. And what is T4? Let me write it here. Okay, what is T4? Minus 6, minus 6 here, minus 6, and what is this? 5, minus 6 5. So make a note of this. Make a note of this. Minus 6 2 T1, T2 minus 4 2, minus 4 5 T3, and T4 finally is minus 6 5. Okay. Stop the video here itself. Mark all these points. No, make a note of this and write it as an answer here. Okay. Okay. Now this is the third question, third part of the third question. Now let us see if there are any questions. Okay. The fourth problem discusses about the others' rooms in the house. Okay. So it says Rian's room door leads from the dining room. Okay, which has the length 18 feet and width as 15 feet. Okay. Okay, now, and they are saying the length of the dining room extends from point P to point A. Okay, the length of the dining room, and it is actually attached to the bedroom. Okay, okay, let us look at that in the diagram. Okay, now what they are trying to say is, so this is the current diagram that they have given, and they say that there is a door here. You remember there is a door here. D1 R1 is a door, and attached to this bedroom and the walls of the bathroom there is a hall, they are saying. Okay, it is a dining room which has 18 feet length, okay, and 15 feet width. Okay, and that length actually extends from point P to point A. Okay, so concentrate on this point first. They are saying point P to point A. What are point P to point A? From point P to point A is the length of the dining room. Okay, and that is actually 18 feet. You can see from point 6 to minus 6 to plus 12, if you take, that is the length, that will be 18 feet only. Okay, and 15 feet is the width. So from here you have to imagine, from here onwards it is towards the downside, there is 50 feet width of the dining hall. So we need to fit in that first. Okay, so what they are saying is sketch the dining room and mark the coordinates of its corners. We have to first draw that. Okay, so we should be actually drawing that on a graph sheet. Okay, let me take that graph sheet and draw this first. Okay, it is 0, as you know, it is 0, it is 1, okay, 2 3 4 5. Okay, so somewhere so if, let me see that whether it is possible to represent that or not. Minus 11, it is minus 12, minus 13. Okay, so minus, okay, assume that minus 15 is also there here. Okay, somewhere minus 15 only, so it is actually minus 14, but there is no space, so I assume that this is minus 15. Okay, so you have to practically you have to draw mark a point minus 14 here and then minus 15 over there. Okay, let us for the identification of the coordinates, I have represented this as minus 15, but it is actually minus 14. Okay, now let us see what they are saying. They are saying, first of all, 18 feet width and 18 feet length and 15 feet width. Okay, and it starts from point P to A. Okay, so point P to point A, this is first point, and this is A. And what is point P? Minus 6 0. And what is point A? It is 12 0. That you know already. Okay, so let us identify those first. It is point P. Okay, point P, and it is minus 6 0. And this is point A. This is point A, which is 12 0. Right? And what else? The 15 feet width. So from here it is 15 feet somewhere. Okay, so the room starts, the left side of the room starts from this point and goes till the point. Okay, now assume that this is point 15 here. Okay, so it goes like this. Okay, and what will be the corner here? The corner will be this point. And what is this point? Now assume that PA. Now let me mark this as M and this as N. Okay, let me mark this as N. Okay, now what is the x coordinate of N point then? Minus 6. And we know what is the y coordinate? Minus 15. Correct? Minus 15. And similarly, what is the point? X coordinate of the point M is 12. We know that. Okay. And what is y coordinate? That is minus 15. Okay. So attached to this is actually a bedroom. This is actually bedroom, and this is bathroom. Correct? This is bathroom. And from here to here it is PAMN. Okay, it is PAMN, PAM and N. This is actually the dining room. Okay, okay, now let us see what they are asking. They are asking us to sketch the dining room. Okay, we have sketched the dining room and mark the coordinates of its corners. Okay, so let us write as shown in the graph. As shown in the graph, the dining room it is dining room only, right? Okay, so it is dining room coordinates are what are the dining room coordinates? Are PAMN. Okay, let us write what is P. What is P? We know that it is minus 6, okay, towards x-axis and 0 y-axis. A is 12, okay, x-axis and y-axis 0. Okay, it is on the horizontal x-axis only. Okay, and M, we know M's x coordinate is 12 only, and minus 15 is the y coordinate. And similarly, N actually comes in parallel to point P, where the x coordinate is minus 6 and y coordinate is minus 15. So these are the coordinates of the dining room. Okay, now what is there in the second part? What is there in the second part? After we sketched the dining room, okay, what is there? So they are saying place a rectangular 5 feet to by 3 feet dining table. So they want a dining table which is of width 5 feet and length 3 feet. Okay, so they wanted to place the dining table precisely in the center of the dining room. So they want, so this is the dining room, and exactly in the center of the dining room they want to place that rectangular 5 feet by 3 feet dining table. Okay, we have to write the coordinates of the feet of the table. Okay, now here you need to understand what do you mean by exactly in the center. Okay, so identify, you see that it is 18 feet. Listen to me carefully. It is 18 feet length. They are calling it as length, but usually horizontally we call them it as width. Okay, but assume this is that. Okay, and it is 15 feet. We know that. Okay, assuming I am placing 5 feet by this way, 5 feet and 3 feet. This is the table. I need to place this exactly in the center. So to place any object of the similar shape inside the same shape object exactly in the center, what we usually do, listen to me carefully, what we usually do is we will find out the top left corner of this inner object. Inner object in our case is a table. Okay, top left corner. How do I find the top left corner? Is take the half of the width of this room. Okay, so that will be 9. Okay, half of this. Okay, so let me write half of this, which is 9. Take the half of this also, that is 7.5. That is 7.5. Okay, and then from that half of the width of the outer object, subtract half of the inner object. Okay, so when I take this, I have to place the half of the inner object exactly here, right? So then only it will come uh, precisely in the center of the outer object. Okay, okay, now take the half of the inner object, that is, what is that? Width wise it is 2.5. So it is 7.5. Sorry, not 7.5, 6.5. Correct? 6.5. It is that 6.5. This is 6.5. And similarly, it is 7.5 minus 1.5. Half of this. This is 1.5, right? It is 7.5. So this is 7.5. From here, 1.5 if I subtract, so this will be 6. Correct? 7.5 minus 1.5. This is 6. So what is this top left corner point? Is x coordinate from left. From the left wall, it is 6.5 feet, and from the x axis, it is 6 point below the towards the negative y axis. So if you place the top left corner of the inner object at a point, say suppose it is T1 table, the table's top left corner T1. So it will be like 6.5 from here. See, from minus 6, 6.5. It means it is 0.5, right? 0.5. It is plus 0.5. So I am taking it from minus 6. So it is 6.5 means it goes towards the positive x-axis, that is half, 0.5. Okay, and then minus 6. So this is the coordinate where we have to place the top left corner of this table. And to this x-axis, if you add 5, you will get T2. You will get T2. That is this point. Okay. And to the y-axis, if you add 3, because this is 3, right? Y-axis, if you add 3, you will get T3. Okay, so once you get this, so 0.5 it remains x-axis, and to the y-axis if you add 3 you will get T4. So this way you are going to get all these coordinates of the feet of the table. I hope you understood this. Okay, okay, now let us do the same thing over here. Okay, now let me erase this and talk about the problem. Okay, how did we do that? We know that we know that length of the room is equal to 18 feet. Okay, that is given. That is given. And similarly, width of the room Width of the room is 15 feet. Okay, this is also given. And what is the table size? It is 5 feet by 3 feet. So considering 5 feet as the length and 3 feet as the width, okay, uh, and length of table is equal to 5 feet, okay, and width of the table is 3 feet. Correct. Now we have to find out the top left corner point where we need to place the first top left corner of the table. Okay, so how do we find that? Let us take that in the next slide. Okay, now the coordinate for the top left corner of the table, top left corner of the table, top left corner of the table, or you can say the coordinate to place the coordinate to place the, okay, because we are going to place that, right? So now the coordinate to place the top left corner of the table is equal to x coordinate is equal to, so half length of room minus half of length of table, okay. So length of the room is 18 divided by 2, okay, minus half of the table. What is the length of the table? It is 5 by 2, correct. So it is 9 minus 2.5, 9 minus 2.5, and which is equal to 6.5. Okay, 6.5 feet from the left wall of the room. Okay, so let us first identify this. Now y coordinate, is half of width of room, that is for length, and this is for width. Okay, half of width of room minus half of width of table, half of width of table. Okay, now what is width of the room? That is 15 divided by 2, okay, and minus width of the table is 3, right? It is 5 by 3, okay, so 3 by 2, that is 7.5 minus 1.5, which is 6. Okay, so now this is the point, see, minus from minus 6 it is 6.5. so what is 6.5 then? From minus 6 it is 0.5, okay, and from 0 to minus 6 it is 6, okay. So it is this point where we are going to place the top left corner of the table. Okay, so what is this point? Let me identify this point as t1, okay. And what is t1? Towards x coordinate it is 0.5, and what is y coordinate? This is minus 6. Okay, so remember this, is the point 0.5 and minus 6 where we are placing the top left corner of the table. Okay, so let me write that. Therefore the top left corner, the top left corner of the table is placed at placed at T1, which is 0.5 and minus 6. Why 0.5? You understood, it is 6.5 from the left wall of the dining room. Okay, so that is 0.5. And why minus 6? Because it is the 6 feet from the x-axis. Okay, so that's why. Okay, I hope you understood this. Okay, now since we have placed the top left corner at a point T1 minus 0.5 minus 6, what is the length of the table? That is 5 feet. So from here 5 feet if you take, it will go till 5.5. Correct? 5.5, this is that point. 5.5 and minus 6 is the y coordinate. So this point is T2. And what is that? X coordinate 5.5 and minus 6 is the y coordinate. Okay, so this is the table of 5 feet, and from here it is 3 feet. From here it is 3 feet. So what is minus 6 added with 3 feet? It goes till minus 9. So the point here will be, this is that point, minus 9. And minus 9, that coordinate is T3. Okay, the third coordinate of the table. And what is that? 5.5 is the y coordinate and minus 9 is the x coordinate. Okay, sorry, minus 9 is the y coordinate and 5.5 is the x coordinate. And finally, if you add up this, okay, sorry, till this point you have to add this, and this is the table. Okay, so this is the point T4. What is T4? With x coordinate as 0.5 as usual and y coordinate as minus 9. So this is how the table is placed exactly in the center of the room. Okay, hope you understood this. Okay, let me write the coordinates. Okay, so the first coordinate we have already written, 0.5 minus 6. Second coordinate is 5.5 minus 6. Okay, the other coordinates are, I can say the other coordinates are placed at T1 with, I can say, with the other coordinates of the remaining corners of the table. Correct? Of the remaining corners of the table. Remaining corners of the table are T2. Okay, T1 is 0.5, and from here if you go to T2, that is 5.5, because 5 feet is the length and the y coordinate remains minus 6 only. Okay, and next is T3 where x coordinate remains the same. X coordinate remains as 5.5, and to y coordinate it goes extended 3 feet, so it is minus 5. And finally T4. Finally, T4. What is T4? You can see that minus 5.5. T4 is 0.5 minus 9. Okay, 0.5, because it comes in parallel to T1. 0.5 and minus 9. So these are the coordinates that are required in the question. Coordinates of the feet of the table. Okay. So this is the answer for the fourth question. I think this is the last question. Okay, so this completes the exercise set 1.2. All the 4 problems we have resolved. Okay, so let us stop our discussion here only in this session and continue with the distance between the 2 points in the 2D plane in the next class. Okay, thank you.